Unit 3, Lesson 2, we are going to finish the last example for Lesson 1. So let's go ahead and do that here. So solving equations with rational exponents, we're just talking about solving, the process of solving. Again, a lot of that stuff, the same base is helpful in solving. So we've already met the concept in earlier courses. Remember, if you remember Math 20, we did a lot of exponent solving. We do have to do guess and check because we didn't know how to get those exponents down. And now this unit that we're doing today and for this section, we're not going to have to guess and check. You're going to use logs to get those exponents down. Okay? So when we look at this, we have, for example, see Sarah completed a solution by taking a cube root. So she's solving a volume of sphere problem. She's told the total, and she's going to solve it. So, first thing she's going to do, she times it by 3. That's what's here. Then she divided it by 4 pi. So she divided after we times the 3, she divided the 4 pi over. So we know r cubed is that. And so what are we going to do to figure that out? How can we figure out what r is? We can cube root, right? So we can cube root, that's not a problem, so we can do that real quick. This is kind of not the log way. We can get numbers off of there. And Lee's method, he just used the exponent. So he did cube root, which is to the 1/3. That's what their differences are. It's the same thing, and they're just going to get the same answers. The point is that the fractional exponent didn't change anything. So, I mean, that's not too important in terms of different sides there. This is kind of normally what you would do. This is kind of, I don't want to say common sense, but you would say, oh, I need a cube root. You'd cube root. But if you do it to the 1/3, that's the same as well. Okay, all right, so let's look at the examples here, and then we'll move on. So solve for x in the following. Okay, so I have -4/3. Okay, so I have -4/3. We got to ask ourselves, the thing is you got to say to yourself is, how can I get the exponent to be 1? Because we're solving for x to the 1, right? So you're like, okay, -4/3. What times -4/3 gets me a positive 1? 3/4, but negative, right? So I'm going to do -3/4. I know it's hard to see there. Let's rewrite it. Let's go x to the -4/3 times -3/4. So we -3/4 exponents to both sides. And so what that does on the left is just x now, because these cancel, those cancel, they're both negative, so I just get x. And it's the 4th root of 81, right? 4th root of 81 is, we did this one earlier, it's 3, right? 4th root of 81 is 3. And then we're going to cube it and put it on the bottom. Why is it on the bottom? Because of negative, right? So we essentially did this. 4th root of 81 is 3. 3 cubed is 27. Your answer is 1/27. Okay. So this one, how are we going to get rid of the 3/2 there? By 2/3, good. So 3x minus 5, 3/2, we're going to times it by 2/3. So we're going to take 27 to the 2/3. So let's go ahead and do that. So you can kind of see this cancels. That's the point. So 3x minus 5. We have cube root 27 is 3. 3 squared is 9. Okay, again, this is what we're doing. Cube root 27, and we're squaring. That's what 2/3 means. It's in your notes previously. Now 3x minus 5 equals 9. We're too easy, right? Simple algebra. Add the 5. 3x equals 14. X equals 14/3. And we leave that there. Okay, so now lesson 1's done. Okay. All right, on to lesson 2, which is, like I said, even shorter. Okay. All right, so we'll save this one maybe to get warm. I'll put this in the warm-up for tomorrow, the review here. We're just going to go ahead and go right to the examples. So solving exponential equations with a common base. An exponential equation with a common base where the variable is an exponent, use the following procedure to get through these. Write each side with the same base. So that's why we did our change of base. So if you write both sides with the same base, then like Cole was saying, yeah, then the exponent just set them equal to and solve. Equate the exponents on each side. I just said that. Determine the value of the variable. So simply, okay, this one they gave it to you already. 5 and 5. Cool. Same base. That's all that's there. So 2x plus 3 and 7. 2x plus 3 equals 7. Simple algebra solve. They have the same base. Therefore, you can drop the bases and solve for x that way. Minus the 3. Divide the 2. X is 2. Now, this is no different than any other algebra, guys. You can plug this in, and you should get the same value. So, for example, look, we know this is 5 to the 7. The 5 to the 7 is a pretty big number. You don't really need to calculate that. But if I put 2 in, what's 2 times 2? 4 plus 3, 7. 5 to the 7 equals 5 to the 7, right? So you're just checking your work like normal with algebra if you plug the 2 in. So here, now they don't have the same bases. So now we hope, does 343 have a base of 7? Okay, it does. I think it's to the third, right? 7 to x minus 2 equals 7 cubed. So 7 times 7 is 49, times 7 is 343. And now we're good. X minus 2 equals 3. X is 5. Okay, any questions on that? You may not know 343 is a base of 7 right off the bat. Okay, if I'm doing that too fast, that's something you'll take a little longer, and that's okay to take longer there. Okay, so this is what we did at the end of lesson 1 there. 81 we want to be a base of 3, so what's that going to be? It's going to be 3 to the 4th, which is going to make it 3 to the 12x. Right? So this right here is 3 to the 5x minus 1. 81 is 3 to the 4th times the 3x that's there. So that's going to be 3 to the 12x. No, we don't add them. We add them if it was, if you look at the difference in the ones, if it was the, if the 3x wasn't on the 81. So you would add them if it was 81 times 3 to the 3x, then we would add them. Okay, but if it's on it, then we multiply it. Okay, so that's 12x, and now we solve. Okay, 5x, what's that? Oh, 3 to the 5th. Oh, I see. These are my handwriting. I got lost. I see. Thank you. 5. Thank you. 5x. All right, cool. So we're going to minus the 5x is what I was doing. Got negative 1 equals 7x. So x equals negative 1/7. Thank you. All right. Now, this right here is testing all of your exponent knowledge all in one kind of. Because you're like, wait, what do I do with the radical? What can you do with the radical? Tune into the fraction, right? So we have a 3 here. We have a 3 here. We don't quite have a 3 here yet. But we do clearly want a base of 3 everywhere, right? So we'd go, okay, 3 to the x equals, we know 27 is 3 cubed, and it's timesing 2. Whoa, that's a really bad 3. Let's try that again. 3 to the 1/2, as Aiden said. We'll use the fraction of a radical there. Why is it 1/2? Well, we have the 3 is a 1 on it, right? There's nothing there, so it's a 1. The 2 comes from a radical that's normal as a square root, so it's always a 2. If you don't see anything, it's a 2. Okay, so I know you're like, where's the 1 and the 2 at? They're actually not there. They're assumed. Okay, so this is a 1. This is a 2. So that means x equals 3 plus 1/2, which is 3.5, right? You can write 3 plus 1/2 if you want, but x equals 3.5 or 7/2 is your answer. Okay, either of those work because we'll add these. Okay, and the x is already by itself, so there wasn't much solving there. All right, we're almost there. 2 examples that are both short here. Let's look. All right. So a bacterium triples every 6 days. The number of bacteria n present after x days is given by the formula of n equals 3 to the x over 6. How many days until there are 243 bacteria? So where does the 243 go? For n, right? That's the first thing you got to be able to do. So now you have this. And so what do we want 243 to be a base of? 3. And what is the base of 3 there? Anybody know? Okay. 3 to the 5. Good. And so now we're good. 3, 3. So 5 equals x over 6. How do we get rid of the 6? Times it by 6. You guys see, oh no, word problem. That wasn't bad. 30 equals x, which signifies 30 days till the bacterium is at 243. All right. Let's go ahead, and I'm going to need a little more room for these. I got a little bit more work here. All right, we'll finish this stuff. Okay, all right. Let's see here. So we got 27, we got 81. So I'm seeing both of those. I see those numbers. Yeah, exactly. 3, right? So I'm thinking about 3. So I want to make this 3 cubed. And that's times x minus 2. I want to make this 3 to the 4th. Times x plus 3. So I'm going to go ahead and just do those distributions, and then we'll worry about the issue of this being on the bottom. So this is going to be 3x minus 6. This is going to be 1 over 3 to the 4x plus 12. So what am I going to do now? So yeah, we're going to make this whole thing negative and move it up. So we're going to go 3 to the 3x minus 6 equals 3 to the negative 4x plus 12. I just put the negative in front. We can distribute in a little bit. No, because we didn't change anything. Very good question. Titus said, so now you have to go negative the other side, right? Remember, we didn't change anything, right? We took this and moved it up by applying the negative. So we're not timesing stuff by negative. We're just using our exponent rules to move that up. It's a very good question. Does that make sense? Okay, so we just moved it up, so we switched the sign on it. So now we can drop the 3's, the bases. It's 3x. That's a 3, not a negative there. So we're here, right? The negative distributes in. Negative 4x, negative 12. And now we're just solving. Add the 4. Add the 6. So we get 7x equals negative 6. I'll move here in a second, sorry. X is negative 6 over 7. All right. Okay, a couple of things that I really want you guys to get good at. And a lot of you guys that are great with your mental math and stuff like that, if you're going to see it. If you're not, it might take a little longer. But immediately I see, okay, 6 and 5, 2, 16 and 125, but they're flipped, right? The 5's on bottom, that's a base of 5. The 6 is on top, that's a base of 6. But I also notice that the left one has a negative x to the 1/4, or x over 4. So what I'm going to do is, I'm going to flip these and get rid of the negative. Does that make sense? Because if you have an invert, or if you have a negative exponent, you're moving stuff up and down, right? So if I go ahead and flip them, I can get rid of that negative. So this negative here, we're going to write this as 216 over 125, and now it's just x over 4. That negative flipped them for us. And now that's in the form that we like, that's matching up to the right side. And so now we just got to figure out what is our bases. So 6 to the what, 5 to the what? You guys know it's 6 cubed, 5 cubed, right? And so that means we can take the 3 up. So it's going to be 6 over 5 to the 3x over 4. And now we're ready. So you can see we got these to match. And so these will set equal to each other. All right, let's go back here. So we got so first thing I'm going to do is I'm going to multiply by the 4 there to get rid of the fraction. And that hits both there. So 3x equals 12x minus 12, and now we'll just solve. I'll move the 12x this time. Negative 9x equals negative 12. Divide, and now you're done. So that simplified is 4/3. X equals 4/3. Okay, and that's all for lesson 2.